Hi, you scholarly ones. This is the beginning of chapter 10. It's probably one of the harder chapters because there's lots of definitions, lots of formulas, but I absolutely love teaching this stuff because it's talking about solid geometry. And the neat thing about solid geometry, and I'm trying to find my notes here because I thought I had them all up close, is the fact it's a way of taking things from the no dimensions to three-dimensional world. Because remember, when we start with geometry, we start with a single point, which has no dimensions, it's just a location. Then we go to a line, which is one dimension, it has length. Then we go to planes that have two dimensions, and that's when we start studying all the different shapes that are in the planes, like quadrilaterals, right triangles, all those. So then we have to take it now to the next level. We're going to the 3 dimensions, we're 3D. So they call it solid geometries, things that are solid, that have, length, width, and depth. You have all of those. Well, we have to know the different parts, and we have a lot of definitions of these that you're going to have memorized, okay? So the first one is every part, when I have a figure like this, each flat surface is called a face. So if it's a flat surface, it has a face. So on this, you should have 6 faces of that rectangular prism. And yeah, I'm using the technical terms, but you're going to have to get to know those really well. So this is just basically looking at it like this. And there's 6 sides. So you have the 1, 2, 3, 4 going around, and then 1 on each side. So you have 6. Then we also have what's called an edge. Now an edge is just the segment that's formed, all right, when 2 faces hit. Well, you're going to have lots of edges with these. So that's not like abnormal, because you have what's called an edge around the bases, and then you have your vertical ones going up. It's just where any 2 faces intersect. We also have what's called our vertex. Now a vertex really hasn't changed from before. When I had a vertex, that's where the 2 rays had a common endpoint, right? Or the corner, like we had the vertices of the parallelogram. Well, that's still the same. A vertex here has when we have 3 or more faces intersecting, and when you do that, you form those angles, you form those type of figures. So it's really easy to get. In this case, you'd have 8 vertices for that diagram. Now, these would be something that's very important to do, and I know a lot of people won't do this until after the first quiz, and they realize, ooh, I didn't know my definitions. But it's the 4 main solids that we are going to be working with in this class. And they are all different types, but they all really are helpful and useful that when we work with things here. And I actually have a couple here, I'm trying to grab them as I go. And the first one is called a prism. A prism is formed by 2 parallel congruent polygon faces. Those are called the bases, and here they're the ones that are colored in. Notice, and they're parallel and they're the same size. They can be slunk over or they can be together. That's okay, like kind of like a slinky. But those are our bases. The bases are connected by faces that are parallelograms. Most of the times they end up being rectangles, okay, when you work with them. So our bases are connected by the faces, and there's 3 faces in that diagram. Prisms can have any polygon for a base. Did everyone hear me on this? Prisms can have any polygon for a base. So you have to know all your polygon formulas in order to do this. Then the next one is a cylinder. Now a cylinder is basically a round prism. It has 2 parallel congruent bases. 1, 2. Same size, same shape. And then we have a curved surface, which is really called a lateral face, is what we're going to call it. Oh, excuse me, a lateral surface, excuse me. That goes all the way around when you're working with it. So that would be our cylinder. Now just memorize 2 congruent circular bases. Pretty simple. Then we have what's called a pyramid. And when you hear the word pyramid, half of you instantly just went to Egypt. Well, the Egyptians were very good at building those, and that's pretty amazing when you think about they didn't have all the technical measuring equipment we have nowadays. But with a pyramid, there's always a bottom to it, and that bottom is called a base, and it's a polygon base. All right. The faces this time are triangles, and they all have what's called a common vertex. So you have a base, which is at the bottom, and then you have the 3 triangular sides that meet together. And here's just a very simple example of what would be a square-based one, because here's your base, and you see all the triangles come to that one point on the top. Then our last but not least is just really a round pyramid. It's a cone, okay? that should be a CO, make my O a little bit smaller there, C-O-N-E, is formed by a circular base and a curved surface that connects the base to the vertex. So here would be your base, then you have the vertex. By the way, if you were to flatten a cone, it would look something kind of like this. It looks like a sector with the circle as the base. And I know that's a horrible circle, so it's driving me nuts. All right, it's a little bit better. Now we also have another term. It's called a polyhedron. A polyhedron is just a figure, a three-dimensional figure that's formed by 4 or more polygons. It only can be formed by polygons, so circles don't work, all right? So, but they're really cool. So prisms and pyramids are polyhedrons, and you can get some really cool technical ones. And when I was working with it in class, I was showing people some cool nets and stuff on the internet, and you can see these, like, there's one that's called icosahedron, and then you have a dodecahedron, and they're like so cool when you look at them. All right, now I'm going to actually flip this over real quick just to show you the different polyhedrons. Because notice here, that looks like a dodecahedron, which I just think is like the coolest thing in the universe, how that all works with both sides like that. And then we have our square-based pyramid, but notice spheres, cones, and cylinders are not polyhedrons because they do not have circles. All right, I'm going to shut this off for now, and then we'll come back and we'll finish up some other info.